Well, good evening, everybody. So, I hope you're staying warm on these cold winter days. I know here up in Michigan, we're down into the negative numbers, and that's before wind chill. In the past, when I walked through the settings for different inverters, those seem to go over really well and seem to really be able to help folks out. So, I thought now might be a good time to do that for the MidNite One inverter. So, let's get started. So I've done several videos on the MidNite One inverter, including an initial review and some specifications, and I'll link to those here so that if you're not familiar with this inverter, you can take a look at what it is and what it can do. And so this inverter, unlike a lot of others, does not have a display where you can program the inverter. You actually have to use a mobile device and download their app in order to program the different settings for the inverter. So we're going to jump over to my tablet. The app itself might look really large in some aspects, but I wanted to use my tablet as opposed to my phone for this walkthrough because it might make it easier to see the different settings as we walk through them. So we'll go ahead and launch the MidNite Pro app, and we're going to do local access. And you can see that it's listing the two inverters that I have behind me. And I'm just going to pick 125 because I know that that is my primary inverter. And once this loads, you'll see what I mean about images being a little bit larger. So because this is a tablet, it's trying to use the full screen. So this home view is really taking up a lot more space than it really needs to, but we'll just scroll past that and we're going to go right into the settings. I believe I did a general walkthrough of this app several months ago. So I'm not going to go through each menu. I'm just going to get right into the settings. And so with all these settings that we're going to go through, I'm going to give you my thoughts on how I believe they work. I might be completely wrong, and if I am, please, by all means, correct me in the comments so that we can make sure that everybody knows the proper use for these different settings and fields. But if you look under each option, there are little help tips which kind of give you a general idea of what each setting does. So they have this concept of end user settings versus installer settings. Some systems have this, some systems don't. It's more designed for installers and giving the actual homeowner some measure of control without being able to really mess the system up. And so, looking at this very first one, discharge and SOC on grid. So, this is going to be kind of like the floor that you want to use of your battery before it switches over to grid. So you can see right here, it's set to 10% in my system. So when it's in battery mode, discharging from the batteries, it'll discharge down to 10%. And then, assuming you have a grid connection available, it will switch over to the grid. If no grid is available, it's going to keep discharging down until it hits the maximum discharge value set, where it actually shuts the inverter down. The next option is charge by grid. So you can toggle this on and off whether or not you want to be able to charge from your AC input connection. And then the next option, well, if you're charging from the grid, what's the state of charge that you want to stop charging from the grid? I believe that force charging is going to tell your system to charge regardless of the state of charge. Now, I believe you do have to be in a grid mode to where your inverter is running off of grid power for this to work. So if we look here, enable this when you are allowed the inverter to charge from the grid. When it's disabled, the inverter will charge from solar or the generator port. The time-based controls is going to give you 3 different time slots where you can tell the system that you want it to only charge or only discharge. I believe this is more for a grid connected feature to where it's going to try and discharge the batteries and actually push power back up through the grid. So if you have it set to discharge between 10 a.m. and noon, it is going to try and push as much power as possible up to the grid to discharge your batteries during that set time frame. And then charging is going to pull power from the grid during that set time frame. And then the bottom option is setting your Wi-Fi so you can remotely view what your system is doing any place you have an internet connection. So we'll click the gear in the top right hand corner to go to the installer settings, and we need to log in. And this password is super admin. And now it's going to give us 5 different menus which control the various aspects of this system. So the first one is your power control, where you are going to define how the power of your system is supposed to flow. The first option is working mode. So you can set your inverter in a self-consumption mode, which means that it is going to try and basically provide power for all your loads from battery first for as long as it possibly can and pull any excess power needs from the grid. Grid feed in priority is an option for you to sell back to the grid to be able to push excess power from your system, whether that's from solar or your batteries. In a self consumption mode or a cell to grid mode, you have the ability to connect current transformers, CT clamps into your main panel and actually push power from your inverter through your AC input connection and supply power back into your main grid panel without it being directly connected to the output of the inverter. The off grid work mode ends up kind of changing the way that the AC input works on the inverter. Anytime power is detected on that AC input, the inverter is going to switch over to that AC input connection. It's kind of like the way Victron works for like the RV aspect. So you're running off batteries and then you plug into shore power and you want to power all your loads from shore power as soon as that shore power is connected. That's kind of like what off-grid mode does on the MidNite inverters. If you have an AC input connection, it's going to pass all of your loads over to that connection. I kind of wish that it could be controlled a little more so you could decide whether or not you want that relay for the AC input on and off. But at the current point in time, that's not how it works. I guess it's kind of designed for if you wanted to have multiple generator connections coming into the inverter for some reason. You could use the generator smart port as an input, or you could use all your smart ports as smart loads and then route your generator into your AC input. And when power is detected on that input, then it switches all your loads over. Support normal load. So this toggle is really it's going to be for the self-consumption or the grid sellback modes. And what it's going to do is if this is enabled, it's going to allow you to push excess power back through your AC input connection to supply power to loads in your grid panel. So in my case, I still have the dryer and the oven on the grid panel. Well, if I put my CTs on my main connections, which I did test in a previous video, I'll link to that here so you can see a little bit more about it. But the normal load option is going to allow you to push that power back. If normal load is not turned on, it will not try to push power through the AC input connection. Zero export is pretty much exactly like what it sounds. Are you going to allow your system to export power to the grid? Yes or no? If this is turned on, the inverter will prevent power from being pushed past your CT connections. Smart loads. This inverter has three different smart loads: a 30 amp, a 50 amp, and a 60 amp. The 60 amp smart load is going to either be for a smart load or for generator. The 50 amp is going to be for a smart load or AC coupling. And then the 30 amp is only a smart load. And when I say smart load, that what I'm saying is it can be configured when it turns on and turns off. So you can set it based on state of charge, you can set it based on voltage, and once it hits certain thresholds, it will turn that breaker on and off to supply loads. If it's in the smart load configuration, if it's in the generator configuration, it'll pull power into the system, and the same with AC coupling. So if we look at the generator configuration options, we can see we can set a maximum input power from the generator. So basically, what is your maximum power that you want to allow pulled from the generator? The next option, maximum charge power from the generator. So if you've got a 10,000 watt generator, how much power do you want to use to charge from the generator? Well, maybe 2,000 watts charging, and then the rest can supply power to the loads. And in my case, I actually have the grid connected into my generator port so that I truly have an off grid connection. And so the connection only turns on when my state of charge drops to a certain level. But I don't want it to charge from the grid. I want it to pass through power, but I want all my battery power, my generated power, to come from solar. So generator start and stop, state of charge. You can see it's set to 50% as the start level, and then it stops at 100%. If you're using an actual generator, you can set a maximum runtime. Dry force. Do you want to turn the generator on regardless of the state of charge? If it's on auto, then it's going to follow the state of charge or the voltage, depending on how the system is set up. If it's set to on, then it's going to immediately switch over to that generator and supplying power to all your loads from the generator. And then what do you want to run cycle? Do you want to exercise your generator? If you've got a whole home generator outside, do you want to exercise it once a week, once a month? You can program that right into here. So the smart load option on any of these breakers, you can see right here, smart load start and stop by battery state of charge. So when do you want it to start? Which in this case is going to be when your battery state of charge is above 50%, turn it on, and stop it, turn it off once it gets to 80%. And this could be used for if you had a dedicated water heater element to where you needed a dump load, if you wanted to dump excess power once your system is almost charged into your water heater, you could use this. You could use a car charger. So only turn the car charger on when your state of charge is 80% or higher. Just a couple different examples. AC coupling. So this is only available on the 50 amp breaker. You can see you can set a start and a stop state of charge. You have to use a dedicated PV inverter or a micro inverter, which allows for frequency shifting. And so this is going to control when this turns on and when this turns off. It needs to be able to shift the frequency of the PV inverter to tell it to stop sending excess power. And so you can program that frequency based on the specific PV inverter that you have. I believe the AC coupling option and maybe even the generator option need to be enabled when your inverter is in standby mode. Going down to power controls. So if you're in an off grid state, your power control is going to be disabled. It's not needed. If you're in a self consumption mode or in a sellback mode, you'll want to use the CT sensors. I believe the smart meter option is only needed when you have a three-phase system, and that can help track all of your power flow from those multiple inverters. Sensor location, grid side or load side. So that's going to be your CTs or your meter from your power control. I think most folks are going to end up using it as a grid side, and that's what the default value is. Energy flow direction. So the CT clamps that come with the inverter have to be clipped on with the little arrows pointing a certain direction. And if you accidentally clip them backwards, you can come in here to energy flow direction and switch the direction. It only works though if both clamps are facing the same direction. If you've got one facing the inverter and one facing the grid, it's not going to help you. They both have to be facing the same direction, but this option here allows you to use the software of the inverter to switch that direction so that it can track power flow properly. The power derating control method, I'm going to take a shot in the dark at this one. It allows your inverter to control the power based on the minimum phase power, the total power from both phases, or looking at the independent phase power to determine how it can derate. And by default, it's going to be the independent phase power. You want it to look at each phase independently of the other. Maximum feed into grid, that's if you're selling back to the grid. I am not. So I have zero export enabled up above, and then I have this value set to 0. This allows you to basically set in watts how much power you want to allow to push back to the grid. Maximum consumption from the grid. So when you're in a self-consumption mode and say you do not have an interconnection agreement with your power company, this value allows your inverter to always draw a certain amount of power from the grid so that if a large load turns off, it's not instantly going away and then allowing some power to get pushed back up to the grid. By default, it's a 300 watt draw. Looks like you can go from as low as 30 watts up to 500 watts. This was one reason why I actually switched over to using the generator as my grid feed, because I didn't want that power draw always coming from the grid. Time-based control we already looked at from the end user settings. It gives you the ability to set a start and a stop. Charge, discharge, do you want it to repeat? How much power? What's the state of charge? Looking at the battery options, this is going to have all your options for configuring the battery itself. And depending on your different selections in here, some fields will show and hide whether or not they apply to the options that you select. So selecting your battery brand, I guess unavailable would be if you're running batteryless. You can set lead acid, you can set pylon, UZ, MidNite, or lithium battery, no BMS. So some inverters, you either set them up with battery communication or you set it up to lead acid mode. You might have a lithium battery, but just a battery that doesn't have BMS communication. And in those instances, you would end up using lead acid mode. But in this inverter, they give you a lithium option that can be used with no communications. It's just called lithium battery, no BMS. Whatever battery brand you select is going to really change the options that show up below. For the most part, Pylon, UZ, MidNite, and Lithium are going to show the same options. But if you switch to lead acid, it's really going to show you a lot of different options specifically related to lead acid batteries. So you're going to program in your battery capacity. You're going to program in the impedance on your battery cable. What do you want your floating charge, your bulk charge to be? What do you want the equalization voltage to be? And how long do you want it to hold at that equalization voltage? What's the maximum time frame that you want to let that equalization charge happen? How many days do you want to go before you perform another equalization on your battery? You can go from 0 to 90. There's a toggle to force the equalization charge now. The inverter will try and track state of charge. It's not going to be nearly as accurate trying to do it with lead acid batteries, but it's going to try and do that if you have it set to state of charge, or you can set it to voltage. You can see a lot of the same start and stop options, but lead acid batteries do give you the ability to set the absorption time. It's a minute time frame. It looks like you can set it from anywhere from 0 to 65,535 minutes. I don't know why you would ever want to absorb that long, but hey, you can. You can see I've got the pylon protocol selected right now. So it wants to know what's the battery address. Do you want to control your different settings based on the state of charge of the battery, or do you want to use the voltage? And if you switch to voltage, it will change all fields related to state of charge and show voltage instead. So you can see start, stop voltage, discharge voltage. Down at the bottom of the screen, stop charging battery voltage. But I want this to be state of charge. It's just a little more accurate. So discharge and charge to is going to be the maximum values that you want to discharge your battery from, period. So what state of charge range do you want to allow your battery to charge and discharge? So I want it to charge to 100%. Some people might want to charge to 90%, charge to 80%. This gives you the ability to set that top end. And then what do you want it to discharge to as a floor? Now, you'll want this value to be lower than your switch to grid value if you have a grid connection, because otherwise the inverter is going to turn off before it even switches to grid. So keep that in mind. A recovery charge is kind of like an emergency charge from the grid or from the generator, I believe, with the values that we have set right here. If they get down to 10%, it is going to try and charge from the grid or from the generator, whichever is available. It wants to keep your battery from getting too low. Discharge end, state of charge on grid, we saw that back in the user settings. Right here, it's set to 10%. These do mirror between the user settings and the installer settings. Maximum charge power, 10,000 watts. Maximum discharge power, 10,000 watts again. Maximum grid recovery charge power. So that's how much power do you want to charge from the grid in the event that it ends up using that start and stop recovery charge a few lines above. The charge by grid toggle here, again, same thing we saw with the user settings. Stop charging value, again, same thing. Maximum power, 10,000 watts to charge from the grid. Minimum initiation startup battery when off grid. So this field is designed to require your battery to be at a certain percentage if you hit that end of discharge shutdown value. So that discharge down to right now is set to 20%. And if you have no grid connection, it wants your battery to get up to 25% before it allows your inverter to turn on and start inverting power. When your battery gets too low and your inverter shuts down, then the sun comes out the next day, it kind of prevents your inverter from turning on, turning off, turning on, turning off, turning on, turning off when the sun starts to recharge your battery. It wants your battery to get up to a certain percent before it allows it to start inverting power. I hope that makes sense. And then force charging is the same as what we talked about before. Under the general section, low voltage ride through. So I think this is going to allow your inverter, if you have a large load and your voltage on your battery ends up sagging because of that large load, it's going to allow the inverter to handle that lower voltage from your battery a little bit longer than it would be able to normally. I think we saw this when I did the bounce house blower test, firing up multiple bounce house blowers on this inverter. The battery voltage actually does sag down, but the inverter allows that because this option is enabled. It kind of assumes that it's only going to sag for so long, like when a motor ramps up, and then it's the voltage is going to snap back up. So do you want to allow your inverter to try to handle that limited sag of battery voltage? Anti-islanding is when you have a grid connection and you are either selling back to the grid, or I believe it also works with the normal load aspect. So when anti-islanding is enabled and your grid goes down, then the inverter will stop trying to push power through that AC input and send it back to either your main panel or to the grid. It's a big safety feature to prevent power from going on the grid lines should the grid go down and alignment is working on it. PV insulation resistance protection point, as well as PV leakage. I'm not even going to act like I know what those are officially for. I know they have to do with a safety feature. I'm guessing with both of these, it has to do with if it detects some kind of a voltage short or leak on the PV lines or the PV panels, it will then disconnect the PV or prevent charging from the solar panels so that there's no accidents. Derating, this is another one that I'm not exactly quite sure what it's for. It's under a protection header. It can be set from 0 to 110%. I believe it's actually for the ESS system. It might be a requirement when you are pushing back to the grid, selling back to the grid. I'm not sure. Down under other, there's three options. Single phase, which is going to be, it's not a 120 volt single phase, it's a 240 volt single phase, as opposed to 12240, which is the second option, UL split phase. So if you want your inverters to only utilize 240 volts, then you would have it on single phase. If you're going to use 120/240, then you want UL split phase. And then there's also a UL 2 or 3 phase. Looks like it's for 2 phases of a 3-phase system. I'm not quite sure what that means. The next option, if you are configuring a 3-phase system, you need to basically assign which inverter is going to be what leg in that 3-phase system. Is it going to be L1, L2, or L3? Buzzer. Do you want your system beeping when you press the button on the side of the inverter? I'm not quite sure what the DRM function is for. It's another one of those options that I believe it's for grid interconnectivity. Parallel mode, if you're having 2 inverters stacked and you're paralleling their outputs together, you need to enable this. And then parallel the system battery. Well, is each inverter sharing the same battery bank, or is each inverter using its own battery? I actually have not tried the battery connect independent. I don't know how it works. The 2 behind me are sharing the same battery bank. And so the primary inverter sends the state of charge and voltage information to that secondary inverter. Looking at the grid sections, the grid standard code, there's only one option, the US IEEE 1547. Maximum input power from the grid. This is the maximum power including the pass through to loads, as well as battery charging. It can go from 0 to 24,000 watts. If the breaker connecting the inverter to the grid is less than 100 amps continuous, basically 125 amp breaker, then this value should be set to less than 24,000 watts. If it's connected to a weak grid or high demand charges, you can use this to limit peak grid power and have solar and batteries meet that peak demand instead. The first boot and reconnect boot, I want to say by default, this is set to 300 seconds, which is like 5 minutes. So when you first press the button on the side of the inverter and tell it to start inverting power, it has to go through this countdown. Basically, it's a safety check window required by utilities for grid connected inverters. Well, 5 minutes takes an awful long time. So you can come in here if you're not selling back to the grid and change this value to 10 seconds startup time. And then the percentage is going to be the ramp up rate when it first turns on. So by default, it's 20% per second ramp up. And it's the same with the reconnect and boot. I'm not sure if the reconnect is supposed to be for if you have an overload or something, when does it switch back? A lot of the rest of these settings, they're going to be the allowable ranges for your grid connection. These probably shouldn't be changed unless you consult with your distributor first to get their recommendations. They're here to allow you to correct some grid issues, but I wouldn't go messing with them without hearing from your distributor or from MidNite directly. So you can see there's multiple protection levels. You've got a high protection for frequency, a low protection for frequency, and then there's like a level 1 protection and a level 2 protection. And then you can see the times that they have to hit that threshold. You know, it can deal with 58.5 hertz for, what is it, 300 seconds, but then it can only handle 56.5 hertz for 160 milliseconds. And you can see it's got the same for voltage as well, levels and then thresholds. Reactive power control. This is another one of those areas that I really don't understand what they're for. I would imagine it's probably something that you, again, shouldn't change unless you consult with your distributor or MidNite directly. And then the communication section. The only thing in here right now is just setting up the wireless connection for your wireless dongle. Once you configure a wireless connection, I don't know if there's a way to actually turn that off outside of trying to save bad credentials or physically removing the wireless dongle. I did find out from MidNite Solar that on their website, if you go to the product specifications and under the documents section, they do have this MidNite Pro flow sheet. And so this is really a great resource that you could be able to print out to help walk through the different settings on the inverter. And hopefully this can help be a resource for you as well. It'll go through and explain the different work modes. It probably does a whole lot better job than I did, and it's probably a whole lot less confusing than my ramblings. So you can always go ahead and print this out. And I would personally keep this with your manual so that you have that easy reference right at your fingertips, being able to know what the different options are. So hopefully this helps. I know some of it's probably just super confusing, and really my ultimate goal is to try and pass along any information that I have, trying to make it easy for anybody to understand. So don't forget to print that resource out, save it, bookmark it, whatever you need to, because it's going to be a real help to you. And that way you don't have to try and come back to this video each time and figure out what an option is for. So Again, hopefully it helps. If you've got questions that I can try and answer, please leave them in the comments. If you know what an option is for and I was completely wrong, uh, leave it in the comments below so that everybody can see it. And if you can do me a favor and timestamp what part of the video you're talking about, because that not only helps me, but it also helps anybody else coming back through looking at the video in the future. They can see exactly what is being corrected as well. So with that, I'm going to let y'all go. Y'all stay safe, stay warm, and we'll catch up with you later.